Alrighty folks, for part 2 of the rotating base for the Quorn, this is the base I took it out of the 5C chuck. I got a little ding here, inclusion. I don't think I did that machining it. I think it was a little hole in the casting there, but I'll have to figure something out to do that. I really don't like that look and don't like how it catches, but overall I'm pleased with how this came out, the rotating base. And it fits great on the mounting part there. You can see the little stem there. It's not too loose, moves smoothly. It'll tighten down good when I put a ball handle on this part here, but it does stick out a little. It's a little high. I noticed that. I don't know if that's a big deal or not, but it's interesting because it would be quite a chore to try to put this thing back, the mounting part back in, and remachine that 45-degree cone and make this whole thing shorter. I'm pretty sure I really don't want to do that, so I'll have to see about that. Anyway, it'll work, I believe, as it is, and I like how it fits and everything, so I'm pretty pleased with how that came out. I'm real pleased with the 60-degree undercut. I don't know if you can see that very well. I'm doing this on a Saturday, and I'm near a window to get some of the natural light. Hopefully you can see how that undercut works down there. Let's see if I can, the little kind of dovetail groove. There you go. You can see that a little bit over here. So it cut nice. Now I'm getting ready to make the stop blocks and the V blocks, and so I got out my little collection of scrap steel, nice cold rolled steel pieces. These are too big. They're 5/16 inch thick. I might be able to use them, but we'll see. Here's another example, something that I machined when I did the expansion links on my locomotive. I used this piece of steel and I soft soldered the expansion links down to this, and I put this on my rotary table and machined them that way. So I kind of keep my little jigs and so forth together, and this is quite interesting to me. This is actually the block that I used. You can see the soft solder connection and the little holes. This is the actual piece that I used when I machined both the stop blocks and the V blocks, the V nuts for the George Thomas rotary table. I can tell that because of the markings up here, the saw marks and the drill holes, and also the fact that there's a machined angle on a piece that's silver soldered to a square chunk. But also notice these little marks here, the little center pips that I put in. These are the points A and B, there we go, that I used for cutting the angles. So you set those, and then you can just move. You machine one part and then you can move it up and machine the other. So use the same piece of scrap block. And I got to looking at all the different pieces I have, and I found this. This is fascinating to me. This is another piece of 1/4 inch angle iron. I don't see if you can see that. You can see the little marks on there, and maybe you can even see where I wrote A and B, there we go, on this. So I was thinking about using this, but I guess it worked out well on that part. So I'm actually thinking about using this piece now, and like I'll unsolder that, solder this piece to it after I mark out a new A and a B for the dimensions, noting that the outside diameter of this thing is 3 inches versus 3 3/4, so I have to make it all smaller. I don't want to go into the dimensions right now. I've ciphered it out on paper, but I will try to make them first, and if I do it right, then I'll report back and do a couple more segments showing the dimensions and how I machined it a little bit. So, but that's the plan anyway, is to I'll mark out the dimensions on this piece of angle iron, soft solder it to that peg there that I can use in the 4-jaw chuck, and then I'm thinking I should be able to machine the outer blocks first, the stop blocks from this piece, and then I can cut them off and then use the same piece in a different spot at, say, spot B, and machine the V blocks for the that'll go inside the dovetail groove. Naturally, I'll have to then, once I have them, I will need to machine a little surface that they can be soldered to again, so that I can machine the backs of them, the dovetail angle in them. but we'll cover that as we go along. Hey everybody, I decided to completely remake my stop blocks, and so I've set up soft soldered a new piece of angle iron. This is 1/4 inch thick angle iron by about 1.5 inches in dimension, or I guess it's 1 3/4 dimension to this 3/4 inch steel block that I've been using, square steel block. I've used this in the past, so this is a particularly nice job of sweat soldering the two together. I tinned both sides and then put them together and let them cool. Now I'm getting ready to chuck it in the forejaw, but I thought I'd show this because it looks pretty nice. This lower mark here, this is going to be it's 1.655 inches from the top dimension of this 1/4 inch angle, and that will give me the right outside radius for the blocks. Okay, and so I'll turn that, and then I'll turn it to the right thickness, and I'm going to make mine wider than the rotary, the George Thomas rotary table. I think I'm going to make them about 7/16 inch each. So by the time I get done, it's going to be almost an inch, which will be fine because I've got the V-stock left. And the next thing I'll have to do, and what the closer in mark is, I'll move this block in the forejaw, center it again with my rotating tailstock here, and once I center it, then I can tighten it down and I can turn the outside radius, and that will become the soldering place to fix the V stock. You'll see more what I'm talking about if you don't understand, but just thought this is a pretty nice example, and I'll keep you posted as I go along here. Hey folks, I'm going to delete all the other videos I shot about this. I finally got the idea right, and I just finished turning, went ahead and made an inch plus 32 thousandths on the inside and outside here, and I used the boring bar, and I just wanted to show the lineup. This is the technique I use for lining up the little pip marks. I've retracted the rotating tailstock from the spot, but that's how I line it up on the point of the rotating tailstock, and then just tighten down the forejaws, and it's really easy that way. So now that I've finished this, I can lay out for the cuts, and these will be the stop blocks. So I'll lay this out, drill my holes, and make my cuts. And while the part is still in the forejaw, I use that as a handy grip to lay out where I'm going to drill my number 27 clearance holes for the 632 screws. And I laid out the lines for where I'm going to cut it to basically have 2 1/2 inch wide stop blocks, 1/2 inch tall and about 1 inch wide. Over to the... And here I'm drilling the holes, the number 27 holes for the 632 screws. I drilled little pilot holes first, not pilot holes, but use the center drill. I love these long center drills. Drill the hole here, and the next thing I'll take this over to the bandsaw. The first time I made the set of stop blocks, I used my little saw in the mill here, the saw blade, and it worked great, except it got so hot it melted the soft solder. So, and it also cuts a lot wider than the bandsaw blade. The bandsaw blade's only 20 thou wide, so I'm going to take it over the bandsaw and cut that out by hand. I will not be videotaping that because that's a two-handed exercise to control and make sure I don't hurt myself on the bandsaw. So I usually hold the work with a wrench if need be. I'll bring it back and show you the finished product. Hey everybody, when I mentioned holding this with a wrench, this is what I meant. I use a vice grips, keeps my fingers well away from the bandsaw, and as you can see, I've just finished cutting off the 2 stop blocks, and they came out pretty good. Let me show you. This is literally just off the bandsaw. They're still warm, and I haven't even filed them or polished them up at all. So it came off clean. The bandsaw, as I mentioned, the bandsaw blade's only 20 thou wide, so it leaves a lot of material there. I'm really pleased with how that came out. Both of them look good. So I'll clean them up, file them, polish them a little bit. But let me show you, compared to the other ones here. There's the original 2 that I had drilled a hole, clearance hole for a number 10 because I thought I'd use a 1032 screw, but it's way too big, and as you can see, the center of the hole was just off, so that's why I remade them. So I'm pretty pleased with this. These things will clean up nice. So next, I'll remount the, whoa, this is my new V-block material here. I'll remount my little block holder using the closer pin. I'll do a separate video of that. Hang on. Okay, so here is the second take on making the blocks and so forth, the V-blocks and all for the Quorn. What I've got now, I've got that bar that I showed you. I've just sawed off the stop blocks, and I've got the hole lined up. This is the I think it's 1.325, which is lined up. It's held in place now. All I got to do is tighten it down in the forejaw and keep it centered like it is, being held in place with the rotating tailstock. And then tomorrow I'll be able to machine the outer surface here. I can machine a radius, the 1.325 radius, and just so it matches, my hand is messing up the camera, so it matches the outside radius of this piece will match the inside radius of my V-block stock, and then I can adhere the V-block stock to the outside of this and cut the 20-degree angle. So I'll show that tomorrow. Alright, here I've turned down, after it's sawing off the new stop blocks, I've turned down the outside radius of this. This was the dimension here from the outside of this 1/4 inch angle iron was 1.325 inches, and that's given me the perfect outside radius to solder the, sorry about the camera, the V-block stock, the new V-block stock to. So that'll be the next step. I'll take it out of the lathe and tin both sides and sweat the two of them together. Need to be careful. I used regular solder here, soft solder on the outside, so I'm going to have to wrap this in something, some wet rags or something, because I don't want to melt the solder and have it all fall apart on me. And here we go. I've sweat soldered the V-nut blank onto the modified holder that I have, so now it's just a matter of putting this thing back in the forejaw and cutting the 2 V-grooves, and hopefully I did a good enough job with my soldering. I got a real good tinning on this surface on the V-block blank, or excuse me, the V-block blank, and I got a decent tinning on here, and then I squeezed it together with a vice grips and heated it up, and I had wet rags wrapped around this part so it didn't come loose. So we'll see in a minute when I put it in the lathe and start to turn it down the 20-degree angles on either side. Really the only tricky part is do 20 degrees on one side, 20 degrees on the other, and the thickness here for mine, it's going to need to be about 220 thousandths of an inch thick, so because that'll be the exposed portion, if you will. That's how wide my groove is on my rotating base. Thought I'd shoot a quick video of just making an angled cut. This should be about the final cut, maybe one more cleanup pass. You can see just little slivers are coming off. I've already cut the right hand side. I'm cutting the left hand side now. Just feeding in on the cross slide, top slide, whatever you want to call it. I used the same angle setup as I showed before when cutting the 20-degree angle into the rotating base itself, because you run out of the scale here, so I had to use the actual Starrett protractor. I set it and I just held it against the chuck, jaws, and the side of the top slide. Let me cut the thing off and I'll show you. I don't want to keep this going forever. But you see, you take the cuts. I did the right side first with a different tool, and I'm using a cutoff tool now just to make this. And I've got it right down to right at 220 thou, which is the thickness of my my slot. So I will double check things. If I need to take another pass, I'll probably file this edge up a little bit because it's a little rough, but just, you don't want to make it too far undersized. But this is the part that sticks out of the rotating base, and that'll have the holes drilled and tapped, and then I'll just cut that into 2 sections, but I'll show you that as we go. Okay, and after carefully measuring and everything, the acid test, of course, is trying a test fit. And as you can see, this thing barely, the way you can tell if it fits okay is just wiggle it just a little bit. You can tell if you get a little drag there, it's biting. So basically the edge of the V-block, V-nut stock is catching, so to speak, in the edge of the rotating base. So I think it's the right width. It's just it'll fit inside there. It should be fine. Like I said, I'll file it smooth a little bit anyway, but you don't want to make it too much smaller than the final dimension at all. You just want it needs to be able to fit in there and go around smoothly. So we'll go for a smooth fit. For the next things after this are take this out, lay it out, and drill and tap a couple of 632 holes. And then we can finally heat it up, or we can cut the pieces off, and then we can finally unsolder them. That'll be the last step. I'll take you through that. And here I am tapping the 632 holes. As you can see, I've already got one done. Put the transmission in neutral on the bridge port, and I just tap it by hand. A 632 hole doesn't take much force, it only takes a few seconds. It's a through hole, so it's no big deal. So I'll get this done, and I can take it out of the mill, take it over to the bandsaw, and cut it off. I don't know if you can see the little layout marks where I'll cut it, and then we can unsolder it, and we'll be done. Okay, the V-blocks are drilled and tapped, and I've got them in a vise here, and I just used a coping saw with a metal cutting blade in it to cut it, because it gives a nice thin, clean cut. And I did it by hand, that way I could make sure the pieces didn't get mangled. So that's done. I already cut the edges off, the little two pieces here, and the next thing will be to heat up the torch and unsolder that, and we'll be good to go. I guess I'll wrap wet rags around there again just so I can save this piece, but I'll unsolder it here in just a minute and clean it up and show you what it looks like. And here we are seconds later. You can see where the blocks were soldered on, and here they are. I use these little hemostats to lift them off. You want to have something to handle them when you pull them off, and a nice place to set them down when you take them off. So using this little metal or little piece of aluminum pad strip here for the landing pad. So let those babies cool down, clean them up, and the next thing we'll do that needs to get done is to mill a hole in the bottom of the rotating base. Okay, a bit of a confession. I realized after I started to cut out the back of this piece to make the slot for the V-nuts to go in, I did not cut the depth of the trough for the V-nuts, the correct depth. I had relied on the radius, so it was slightly more than half of the depth that it needed to be. So happily I've just recut the depth and recut the angle here. So just wanted to point that out. Make sure if you're using your DRO that you don't rely on the depth feature. Remember the difference between radius and diameter. Okay folks, kind of a final wrap-up video on this project about using the Dovetail Groove. I am really pleased that I went ahead and did that. Here you see a 632 screw in here, just an ordinary screw for now. Obviously eventually I'll be making little threaded rods and to be able to use the Quorn ball handles. There's a little inclusion that was in this casting, and so this part is assembled there. As I mentioned, I goofed up at first. I didn't make the groove deep enough, so I had to go in and redo that. I realized that when I cut the slot, this little window here for the nuts to go through, but got that fixed. And here is one of the nuts, the V-nuts, inside the groove, just sitting there. As you can see, there's a little, it's a good fit. It needs to be able to move. It's a little loose on the, as it were, but this is how it fits on the rotary table when there's no tension on it. But when you put the stop block on and then screw it down tight, it makes tension there against the dovetail groove itself. So this one, I've screwed it down. I can't even move it, and it was just finger tight, but I can't even move it. So I am pleased that I did this, and hope that this series of videos has been helpful and interesting to you. The next big thing I have to do, I'll go ahead and publish this video tonight or tomorrow. But overall, this all came out good. Basically, this is a little bit larger than a 1/2-inch slot, and what I did, I just marked and drilled a couple of 1/4-inch holes next to each other, and then milled it out to make an opening to be able to get the V-blocks in. That's all you need to do. Kind of not pleased because I goofed up. I've made this edge a little bit rough, so I have to file that down. But overall, I mean, it'll work just fine. So not a worry. These things go past it and go all the way around. It shouldn't be any kind of issue. The next big thing I need to do, speaking of rework, I do have to rework this tilting bracket. It's aggravating that I have to because I got it just right, or seemingly just right when I first made it. I'm really pleased with overall how it came out, but I've got an idea. I'm going to be putting it in the forejaw. As you can see, it just doesn't sit low enough. It's about 1/8 of an inch essentially of space there that this thing needs to be shortened, this portion here. So I'll take this bolt out and the little lock nuts. I'll put it back inside the forejaw, and then basically I could use a 1/2-inch rod in the tailstock drill chuck just to get it roughly centered there, loosely centered, and then I'll be able to use my dial test gauge and center it perfectly, and I'll just shorten it and have to cut this groove again. So that's going to be a little bit of a drag, but when I set the angle here, well, I'll show that when I do that later, but I'll fix that, and then we should be good to go with the rotating base and the tilting bracket. Thanks for watching, everybody. I hope this has been useful and interesting to you. Appreciate all the comments. Welcome to the new subscribers. Please pass the word. Several of you have commented that you wish that I had, or you're surprised I don't have more subscribers. I'd like to have more. If we got over the 1,000 mark, then I could do some community posts and stuff. It could be a little bit more of a discussion group, and maybe I could be of more assistance to more people. So pass the word. We're close now. Right now, last time I looked, it was around 900 subscribers, so just 100 more, and we could go over the 1,000 mark and really make something cool out of the channel. But I appreciate it, everybody. Thanks again. Hope you have a great day.